is very critical, especially in today's environment, and especially after COVID, okay? Because of the increase in work from home, hybrid kind of an environment, people moving to the cloud, going into hybrid, this kind of a thing. They have remote workforce now. Security is very important, okay? And because of that, there has been a very high increase in the number of cybersecurity attacks, data breaches in the recent years, especially around the COVID period and then after that, okay? And we're still trying to recover from all of that. So our first module is going to deal with firewall, okay? If you're aware about the fact that Cisco has Firepower Threat Defense, or FTD, which they used to call it previously. Now they call it Secure Firewall. Okay, that's what you see. You're going to see the name different in a lot of places. Okay, Cisco ASA. So we're not going to discuss too much about the ASA. I'm going to talk about some of the things because the Secure Firewall, or FTD, it builds on top of the ASA knowledge. Okay, and some of the things are very similar, or exactly the way that ASA is, and when we'll discuss, you'll understand why that is. Okay. Now, talking about the actual CCNP Security certification, Cisco a couple of years ago, or quite recently, I would say, they made a change to their certifications. Okay, so previously CCNP Security, you had to do 5 exams. Okay, so there was one exam for everything. There was one for firewall, there was one for VPN, there used to be one for ICE or AAA. Back then it wasn't called ICE, it was ACS. And then we used to have our WSA, ESA, and those exams as well. Okay, so it used to be 5 exams that you need to do. Now, for CCNP, you need to do 2 exams only. Okay, one of the exams, which is the S score, the 350-701, that's the S score. You need to give that exam. That's a mandatory exam. You have to do it. Okay. In addition to that, you can choose one of the concentration exams. Okay, and there are 6 as you see here, and each one of these exams relates to one of the products or one of the technologies. Okay, so S score kind of covers everything. Okay. It will cover firewalls, VPNs, umbrella, CTR, CTA, a lot of technologies which you might not even have experience with, or you might not even have heard about those from Cisco's perspective. But in S-Core, they don't go into too much detail. Okay, they just skim the surface of the technology. That's it. So no troubleshooting. You need to know a little bit of configuration, what the product is, what the technology is, what the features are. That's what the S score is, okay? The concentration exam is basically where they go into a lot of depth, okay? So for example, if you talk about the SNCF, which is the 300-710, this is specifically for next generation firewall or for firepower, okay? So it will test you on configuration, troubleshooting, design, automation. Okay, so it goes into very detail. So in order to have CCNP Security now, you need to only give 2 exams. S-Core is mandatory, and then you can choose one of these concentration exams. What we are going to concentrate on are 3 exams, which are important. Okay.
Hello, hi dear. Good morning.
Yes, Ramesh. Good morning.
Yeah. So my query is like that we can direct attend the test of 300-710, or we have to first,
you can.
Like, yes, you
can do that, right? Okay. So if you do not give the core exam and you only give the concentration exam, you will be awarded with a Cisco Certified Specialist certification.
Okay.
Okay. If you have to do CCNP Security, you will have to do S-Core, okay? But there is no mandate. And that's a good thing that Cisco has done now. For every exam now that you give within Cisco, you will get a certification. Previously, you had to do 3 exams, 4 exams, or 5 exams before you got your CCNP, okay? Now it's not like that. You can give any of these exams, the concentration exams, and you will get a certificate for each of them, okay? So the 710 SNCF, it deals with firepower or next generation firewall. The 715, the SICE exam, which is specifically for ICE, and it goes into very depth for ICE. Okay, so it tests you on design, deployment, what are the different personas, how to do the configuration, certificates, and all the different features, posturing, profiling, BYOD, MDM, TrustSec. Okay, so it goes into very, very depth. And then the third module that we're going to focus is on the fifth item here, the 300-730, which is the SVPN, okay, which is the VPN exam. And Cisco tests you on a lot of different VPNs, policy-based VPN, route-based VPNs, then VPN from the perspective of firewalls, VPN from the perspective of routers. Okay, Flex VPN, DMVPN, very important topic. Okay, both from enterprise perspective as well as from security perspective as well. And then it also is going to test you on Get VPN. If some of you are from service provider background, you might have worked on Get VPN. Okay, if not, then it's very rare that you will ever come across having to work very in depth with Get VPN, but they do want you to know about that on the exam. Okay, again, it goes into very depth, and SVPN is one of those exams which is very troubleshooting focused. Okay, so you need to know your packet captures, you need to know your logs, you need to know your configuration. Okay, because it's very troubleshooting focused exam. Okay, and then another exam that you can focus on nowadays is the last item, the S-Auto, which is the security automation. Okay, we are going to discuss automation. Okay, from API perspective primarily. So I'll go over some of those things during our training for all, primarily for the SNCF and then for the CISA. Okay, and how you can manage things through API, what do you do with APIs, how you can get started with API. Okay.
So what we are going to cover in this, like in this course, like S core or especially SNCF firewall.
So we're gonna cover SNCF, CISA, and SVPN, which also prepares you for S core as well.
Like it will be in a detail or overview.
It will be in detail. So we're gonna do everything in detail from scratch. We're gonna look at everything in the lab, see how things are configured, how do you design things properly, how do you configure things properly, best practices and everything.
Okay, be honest, I am looking for like only firewall training, FTD. Actually,
right. So we will be starting with firewall first. Okay. So if you're only interested in firewall, just sign up for the firewall part. Okay. I think the networking team will be able to support you on that.
Okay.
So you don't really need to sign up for everything as far as my knowledge goes. Okay. So if you're concerned with only firepower, if you only want to learn ICE, if you only want to learn VPN, you can sign up for each of those individually. Okay. Now, since we will be starting with the firewall part today, that's what I have mentioned in here as part of the outline of what we are really going to cover. Okay, so right from this, from starting, I'm going to introduce you to what firewalls are in general. We're going to discuss the different generations of firewall, what secure firewall is and how Cisco positions it. Okay, how it's different from ASA or the previous generation of layer 4 firewalls, how it's different. Okay, I might discuss if you are in the field and if you want to migrate from ASA to the next generation firewall. Okay, so we're going to discuss, I'm going to show you the tool, how you can do it through FMT. We're going to look at setting up everything from scratch. We're going to do FTD bootstrapping. Okay, see what the basic configuration is, how do you get things up and running, how do you do the registration. We're going to do the traffic flow, very important. Understand how packet flows through a firewall, what are the different processes, how do you, it kind of helps you to develop a mindset regarding the configuration, and then also how do you troubleshoot it down the line. Device management, again, important thing. How do you manage the firewalls? You want to manage it out of band, you want to manage it in band or out of the box, or if you want to manage it through the cloud. Okay, we're going to look at object management, which is really a lot of these firewalls have object-based components. Okay, so if you have to define ports, if you have to define networks, you define objects. Okay, And then the main component of the next generation firewall is the ACP, or the access control policy. This is where you define your rules and policies, how things match, what happens if you don't want to allow traffic, what happens if you want to allow traffic, all of those things. And then some of the more advanced topics that go into the next generation firewall. Okay, for example, network discovery, file detection, file control, and AMP. Okay, malware protection. We're going to look at IPS, intrusion prevention, how it differs from IDS, how you can change those modes on the firewall, what preprocessors are, and then something that goes with the preprocessors is NAP, or network analysis policy. I'm going to discuss that. We're going to look at a TLS or SL decryption, very important in today's time when everything is web-based. Okay, so we have to, or you need to give the firewall the capability to be able to decrypt those encrypted traffic so that they can inspect and investigate the traffic better. And then we're going to look at VPNs, sure, both site-to-site and remote access. So we're going to focusing on the client-based VPNs and then site-to-site as well. And then some of the more event analysis, reporting, correlation policies, okay, a very important thing, a very useful thing when you're trying to set up alerts and everything. How can you do correlation? Okay, and some of the other nitty-gritties of how things work, some of the other features which you might not have listed in here, but we'll be talking about in much more detail. Okay, so this is what we're going to starting with. We're going to be using 7.2 as the version in our lab for secure firewall. Okay, it's because that is the latest, not the latest release, but the recommended release from Cisco. So 7.2.4 to be precise. That's what we're going to do. I'm going to show you how do we upgrades and everything, how do you do backups and restores. So we're going to cover a lot of those things as well. So these are high-level view of the topics. There'll be a lot more topics that we'll be covering during the training. Okay, you might not necessarily see those here.
So, what will be the time for to cover these topics? So, how much we are taking times, like 2 hours in a day and 4 hours on a weekend. So, how much week we will cover like these all the items? So, I'm just want to know how much time.
Right. So, we will be pushing for 5 hours a week. Okay, so 2.5 hours per day. That's what we're starting with. So let's just take this to be about 35 to 40 hours of content.
25.
35 to 40 hours.
35 to 40 hours. No?
Right.
Okay.
Any other questions?
No. Thank you.
Any questions? Okay. Okay, so that was for presentation. Okay, so let me just bring up my whiteboard so we can start things up here. And for the most part during the training, I will be using this blackboard or whiteboard, whatever you might want to call it. Okay, I kind of typically don't like to use slides, okay, because it kind of gets boring very easily. Okay, so we'll be primarily doing through whiteboard, or in this case, it looks like a blackboard. Okay. All right. Let me just some color here. Okay. So we will be talking about firewalls. Okay. Now, just to give you a very brief overview of what firewalls are and the different types of firewalls. So a firewall can be or is a hardware or a software, let's just say a device, okay, which is meant to provide security between network segments. And typically when we're talking about security, we call these network segments as trusted and untrusted. Okay, so how do you differentiate between the two is anytime anything is on the internet, which you don't have control over and it's invisible to you, okay, we put it into that untrusted category, okay? Because obviously if we can't control something and we don't have full visibility into it, which is our internet, we cannot trust it blindly, okay? So we keep the term untrusted specifically for everything on the internet. And trusted is everything that we have visibility into and it's under our control, which is our organization network, okay? Our LAN, our data center, any of the servers that we own, all of that becomes our trusted network, okay? So you basically position your firewall between those two segments, okay? Because you want to protect people going from your trusted network to the untrusted network, okay? And you also want to protect anytime someone tries to send traffic from the untrusted network or segment to the trusted segment, okay? And to kind of depict that, you can have this kind of, say it's your, let's say just your DC or your headquarter, you basically will have positioned the firewall somewhere here. And then, you know, this is going to be your internet, right? So this part here, this is your untrusted network, okay? And this section here, this is your trusted. So anytime we are trying to move our traffic from here to here, right? So the users in your data center, on your LAN, wireless, wired, etc., they're trying to access the internet, okay? They're trying to access maybe any websites, any SaaS applications, Dropbox, Gmail, etc., okay? The firewall protects that. And then it also tries to protect anything or anytime any traffic comes from the untrusted network. So from the firewall's perspective, the firewall is basically trying to either deny bad traffic or it's trying to permit good traffic. That's what the firewall is really trying to do. Okay, so now traditionally, firewalls were used to kind of prevent any unauthorized internet users from accessing your trusted network or from accessing your internal networks, okay? Therefore, all of our data leaving or entering your data center or your organization, it had to pass through the firewall to reach basically its destination, okay? And any unauthorized traffic would basically get denied or dropped by the firewall. And firewall's role in any network is very essential in order for it to provide security. Okay, and there are different ways to design it, and there are different ways to place it in your network. Okay, one of the places that I have shown here, this would become your organization's edge, or sometimes you call this as your network perimeter. Okay, so your firewall also becomes a network perimeter security device because it's sitting at the edge, and it's basically seeing everything that comes in and goes out through your network. Okay, you can also place firewalls in your data center. Okay, again, you can place it within the data center core, or you can place it at the data center edge, so that anytime the traffic comes into the data center or goes out to the data center, it actually protects it. Okay, so you can use the firewalls to protect both your north-south traffic and also your east-west traffic. Okay, when I'm saying north-south traffic, this is kind of like an example of a north-south traffic. Okay, traffic coming in and moving out. East-west traffic would typically be your lateral traffic. Okay, so for example, you have users trying to access, let's say, your Active Directory server within the data center. Okay, so that would be lateral traffic, traffic that stays within the data center or within your network. Okay, so depending upon your requirements, okay, how secure you want things to be, you can place your firewalls depending upon those situations. Okay, so both in the edge or in the data center. In the data center can be in the data center core, or it can be at the data center edge as well. Okay, things clear? Everything, things making sense up until now? Now, there are a lot of different types of firewalls. Okay, there were some older types of firewalls, and then we have some newer types of firewalls. So I kind of like to put them into categories. Okay, so I kind of like to call the first is my Gen 1 or first generation firewalls, and I won't really call them firewalls. Okay, these used to be your routers with ACL. Okay, so if you remember or if you have experience with ACLs on router, that's your Gen 1. Okay, there were earlier firewalls as well, which were Gen 1. For example, Cisco used to have PIX firewall. Packet Internet Exchange. This was the very first firewall that Cisco had. Okay, and it was a Gen 1 firewall. And when I say Gen 1 firewall, I basically means it was a stateless firewall. Okay. Now, stateless firewalls, we also call these packet filtering. Okay. So stateless packet filtering firewalls, they examine the packets as they move through the firewall. Okay. And they are going to examine the header of the packet. And what headers do they examine? Layer 3 and layer 4, which basically means that they will be able to inspect the IP address or see the IP address. They will be able to see the transport. Traffic is TCP, UDP, ICMP, etc., etc. And they would also know about what? The ports, both source and destination. Okay. Through a stateless or a packet filtering firewall, the packet is permitted or denied based upon either of these values. It could be based upon IP address, it could be based upon the transport, it could be based upon ports. Okay, it can be either of these, or it can be based upon all of these values. Okay, and I already gave you an example of this is your ACL, your router ACL. It is a perfect example of a stateful firewall mechanism. Okay, now the decisions that are made by a stateless firewall, they are based on, like I said, upon the source IP, destination IP, source port, destination port, and protocol. Okay, and I like to kind of call them as my 5 tuples. Okay, source IP, destination IP, source port, destination port, and my protocol. This is layer 4 protocol, not layer 7. Okay, and at layer 4, you can have TCP, UDP, you can have, let's say, ICMP, some of the examples for your protocol. Okay, now these are the older generation. Okay, they are not really that useful nowadays. Okay, because these are stateless, they don't maintain any states. Okay, These firewalls, they are very good for applications that use static port numbers and static IP address, which in today's time, it's kind of like far too stretched, okay? Because nowadays everything is dynamic. Your applications, your devices, okay? We don't really rely on static anything nowadays, okay? So stateless firewalls, they are very useful or very good for anything that's static, okay? And again, they are for our layer 3 and layer 4, or you could say that they work up to layer 3 and layer 4, not beyond that. Okay, and one of the bad things about them is, again, they are stateless. Okay, so you would need to. So, for example, if I have this individual here, and say I have a firewall, and he wants to access, let's say, eBay. Okay, the firewall would need to permit traffic, right? So it would need to permit what? TCP traffic to port 80 or 443. Only then he will be able to send traffic out to eBay. Okay. Now, when eBay will respond to the traffic, the firewall will then need to have another rule added for the other direction. Okay, so there would need to be one rule, which would be from the user to internet, and there will be another rule that will need to be added to allow traffic from the internet to the user. Now, this is just single user. So for a single user, if it needs to access HTTP, you need to have two rules. For forward and then backward traffic. Okay, so for traffic and then the return traffic as well. Let's say you have 200 users. Okay, so simple math tells me I need to have 400 rules added. Both from a configuration perspective, as well as from a troubleshooting perspective, it is really a nightmare when we talk about stateless firewalls. Okay, that's why these are the older generation ones. People don't really like to use them nowadays because of how fast-paced today's environment is when we talk about security. So Gen 1 devices or Gen 1 firewalls were improved by Gen 2s. These are stateful firewall. Okay. Now, many of you might not be aware about this, but the concept of stateful firewall was invented by Check Point. Okay, so Check Point was the one. Check Point's current, CEO, founder, Jill Shuard, he was the one who wrote the algorithm or came out with the concept of making firewalls stateful. Okay, and stateful firewalls build upon the stateless firewalls, the functionality of stateless firewalls. But the one thing that they add, which differs from a stateless, is statefulness. The firewalls are able to track connections, specifically connection states. So taking this example again that we saw previously, this user trying to access ebay.com, you need to allow 80 and 443. When this traffic flows through a stateful firewall, the firewall will be able to have a database. And this database will have details about the connection. Okay, so things like source IP, destination IP, source port, destination port. If it's a TCP traffic, then you would have TCP related information, TCP sequence number, TCP state, acknowledgement numbers, all of those things. So stateful firewall is able to maintain a connection state. Okay, and in order to maintain the connection state, stateful firewalls maintain a state table. So this database is basically called as a state table. Cisco on their firewalls calls them as connection table. One and the same thing. Okay, so naming might differ vendor to vendor, but the functionality is the same of what a stateful firewall really does. Now, where is this useful? It reduces the need to have multiple rules added. Okay, so if the same scenario, if we take this with a stateful firewall, if we make this as a stateful firewall here, so our good individual here again, and it's, let's say, a stateful firewall now, and he's again trying to access eBay the whole day for some reason. Okay, stateful firewall, we would need to have a rule which would say, let's say, permit TCP any EQ 8443. Okay, now when this traffic flows through the firewall, this entry gets placed into the connection table. Okay, now when eBay returns the traffic or replies to this user's traffic, the firewall, it checks is state table. If there is an existing connection already present in the state table, which in this case will be because the entry was added, the firewall will allow this traffic to go through without having to add any other rules apart from this. So that's the usefulness of having session tracking or a stateful nature. Okay, so previously, if we, let's say if we have 200 users, our rule count does not change. Okay, so you can have just 200 rules here configured. So it cuts down about 50% of the rule configuration. Much easier for you to troubleshoot, much easier for you to manage as well. Okay, so for this, there's a very simple algorithm that you can remember as far as the stateful firewall is concerned. Anytime there is a packet that comes into the firewall says, is there, let's call this, is there an existing connection? Okay. If there is an existing connection, allow the packet. Okay. If there is no existing connection in the table, check your access rules. Okay. So when this user tried to access eBay, the packet reached the firewall. The firewall said, hey, is there an existing connection? At that point, there was no existing connection in the table. So it had to check the rules. It checked the rule, which says permit TCP any traffic. It allowed that traffic. Because of this rule, the entry was added. When there was return traffic from eBay that came back, the firewall again went through this algorithm. It checked, is there an existing connection? And this time there was already an existing connection. Okay, and it allowed that traffic to flow through without having any additional rules configured. Okay, so this approach here for stateful firewall, it allows for subsequent sessions or return traffic packets to pass through or to be allowed without the need for additional rules. Okay, and all of this is possible because the firewall maintains a state table. And again, stateful firewalls are still layer 3, layer 4 firewalls, just like we have seen for our stateless. Okay, so the Gen 2s or the stateful firewalls, they are an improvement to stateless. Okay, so they do everything that stateless does, which is the 5 tuples, being able to manage the traffic based upon layer 3, layer 4 information. The enhancement that they have is for session tracking by this database. Okay, and every firewall out there, and I mean every firewall, every vendor's firewall, Checkpoint, Fortinet, Sophos, anything, Cisco, Juniper, every firewall out there is a stateful firewall. Okay, so this concept applies to every single firewall out there. Okay, these were a Gen 2. So this was a very important revolution, I should say, within the security world, within the firewall, when Checkpoint invented this concept of statefulness. Okay, and again, Cisco's firewall is no exception to this. Okay, it also does the same thing. Okay, the first firewall from Cisco that was actually stateless, it was ASA, Adaptive Security Appliance. Okay, so with Gen 1, Cisco had PIX that was stateless. Okay, kind of stateless, kind of the first generation one firewall. The one thing that PIX could not do was very good VPN. Okay, so that's what PIX used to lack in. Okay, so Cisco, and I'm trying to just give you a very brief history about how ASA came into picture. So what Cisco did was there was an organization by the name of Altiga Networks. Which used to have a VPN concentrator product. I think it was VPN Concentrator 2000. Okay, so Cisco acquired Altiga Networks. And they then started selling PIX and VPN concentrators. So, and I'm talking this pre-2000. Okay, so in that 1990 period, where we were kind of still revolutionizing the internet, security, and everything. Okay, there were more security solutions coming out steadily, slowly. Okay, so Cisco started selling both PIX, which used to do the firewall work, and then anytime if a customer was very keen on VPN, then they would purchase the VPN concentrator. So VPN concentrator would be placed ahead of the firewall. Okay. Then what Cisco did was Cisco combined both of those products together. And there came ASA. Okay, so ASA used to do everything that PIX used to do and VPN concentrator used to do. And I think this happened in the early 2000s. I think it was 2001, 2002, or 2003 period. I don't remember the exact year. But since then and to date, ASA is still running. Okay, so even though it's a Gen 2 product, but ASA has been one of the most successful products for Cisco overall. Okay, and I think it would be very similar to the collaboration space. Okay, because Cisco has been in the collaboration space, call manager and everything, right from that period, 2003, 2004, and they're going pretty strong in that as well. So ASA, it's still there. Obviously, they don't offer it a lot, and you'll understand why, but it's still there. It is still not end of life. It's still not end of sale. Okay, so it's one of the longest running products. It's very stable. Okay, a very good performing product still from Cisco. Okay, so a little bit of history lesson there. Okay, just so you're aware how the ASA came into this, because when you understand next generation firewall, I'll talk about how ASA evolved into next generation firewall. Okay. Any questions with respect to Gen 1 and Gen 2? Pretty straightforward, I believe. I hope everything is making sense. Okay. Now, the problem with Gen 2 is it's still limited to that layer 4 of the OSI. Okay. So as long as I am giving you, or I'm giving the firewall the port information, it will be able to recognize that, hey, okay, this traffic is traveling over port 80, right? Now, what if in today's time, a lot of organizations don't like to use well-known ports? Okay, so if I'm an organization, I'm hosting my web servers, my Apache servers, I will try not use well-known ports. Okay, I'll try not use port 80, port 443. I'll use some random port from my web server. Okay, now, if I say to my firewall that, hey, you need to deny, let's say I tell my firewall that deny any IP traffic from any to, let's say any IP address as the destination, just a random IP. Okay. Now, I'm assuming from my network perspective that this would be HTTP traffic, obviously. Okay, so I configured this rule on my firewall, and I think that, okay, I have taken care of the problem. Now, what if my users are able to access this website using HTTPS, but 8443 instead? Right? Will this rule or will this firewall be able to stop that traffic? Obviously not. Because
can you repeat that question?
This example that I'm
yeah, correct.
Okay. So what I was mentioning is, let's say if I configure on my firewall a rule which says I want to deny traffic coming from any source and going to some random destination, okay, over port 8443, right? I'm assuming, obviously, that port 80 and 443 are well-known ports for HTTP, HTTPS, okay? Now, as an admin, I've done the configuration and I'm good to go. I'm like, hey, okay, that was my work. I've denied the traffic. I'm good to go. But what if someone is able to access this 172.22.20 over HTTPS, but over port 8443 and not 80 and 443? So this traffic will obviously be allowed.
So my question is like, what is the difference between two? No? like IP address, and in first there is a port ID. And what is the difference between both? Like what actually I set a rule that
Mhm,
one line and
mhm.
second. So what is the difference between both? No?
These two?
Yes, yes, yes.
There's no difference. I'm just trying to explain what really is happening.
Okay,
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 so
okay,
this is basically a rule that I've configured on the firewall,
okay.
and this is a user trying to access this destination, but instead of using port 8443, they are using 8443. So
Yeah,
if
I meant to
this,
say that port number are different. No?
right, port number is different.
Okay.
So this is 80, I'd say /443, okay, /443. And this is 8443, so different port information, okay? So with my firewall configured with this rule to stop or look at only the layer 3, layer 4 information, and if my traffic is flowing over port 8443, my firewall is basically blind to this. If I need to block this traffic as well, I will need to have a second rule configured, which would be again a deny statement, but it will be for port 8443. Then this rule will be. So it kind of still is going to add my complexity, okay? One way to resolve this, or one way to ease the configuration, is with the invention of application layer firewalls. The stateful firewalls, the Gen 1s and Gen 2s, they are not application aware. Okay, that's the exact term that you would want to remember. They're not application aware. They don't really know what is happening beyond layer 3 and layer 4. Okay, so if you have to deny some traffic, you have to make sure that you are denying the traffic for every possible port out there, which is obviously not possible. Okay, so stateless and stateful firewalls are only capable of performing or taking action using layer 3 and layer 4 packet information. Additional capabilities are required for firewalls to provide nowadays what we call as DPI, deep packet inspection. And deep packet inspection, or DPI, it really relates anytime a firewall is application aware. Okay, so anytime you hear the word deep packet inspection, it means that the device is capable of inspecting up to layer 7. Okay, so irrespective of what the layer 3 and layer 4 information is, right? So assume this packet as an envelope. The firewall is able to open this envelope and take a look at what is present in that layer 7 data, or call this as payload. Okay, so if we take a look at the same example again, okay, so now with application firewall, my rule can look something like deny IP any. So my requirement is that I want to deny any sort of HTTP, HTTPS traffic. That's what I try to do here. But my users are smart enough, they try to use a different port. Okay, an uncommon port. This is also a very common approach which attackers or hackers do. They try to use uncommon ports on networks when they're trying to do attacks or do data breaches and everything. Okay, because the firewalls and devices, they are obviously configured to look for anything well known. If I have something that's application aware, my rule can look something like deny IP any 172.22.20.20 EQ, and I'll say HTTPS or HTTP. Now this user can send traffic to using HTTP or HTTPS any port. So it can be 8443. It can be 443. Okay. It can be what, 51,443. It can be any port information. My firewall will be able to stop this traffic because it is now application aware. It is now able to open up this envelope or this layer 7 data and check for HTTP, HTTPS traffic. And when I say HTTP, HTTPS traffic, what it is, from firewall's perspective, if it sees a GET request, right? So HTTP relates to GET request, the very first packet. So when you try to access a web page, the very first request that your browser sends to the web server is a GET request. So if the firewall sees a GET request in the layer 7 packet or payload, it knows that the traffic is HTTP or HTTPS. It really does not need to know whether it's using a well-known port or not. Okay, so you get a more granular control of traffic when you're trying to use something like application layer firewalls. Again, they improve on stateful firewalls. They are still stateful firewalls. But now, in addition to being able to inspect layer 3 and layer 4 data or header, they can now also look at layer 7, the actual user data, which travels within the layer 7 payload. Okay, so this is being application aware or application awareness. Okay. So again, nowadays, this is kind of like a mandatory requirement for any firewall out there, because a lot of our use cases now are based on applications, right? And it's not just limited to HTTP, HTTPS. Okay, let's say I don't want to allow any Facebook traffic. Facebook is an application. Now your users could be accessing Facebook either over port 80.443, or they could be using it over FTP, or maybe any other protocol. My goal from my organization's InfoSec policy or security policy is I don't want my users to be able to access Facebook. Okay, so obviously I cannot create 1,000 rules to block every single port number. But if I have an application aware firewall, I can just say, hey, deny IP any firewall, Facebook. So irrespective of the layer 3, layer 4 information, my firewall will be able to recognize when the traffic is for a Facebook application, or maybe for a torrent application, or maybe for an instant messaging application. Okay, so that's kind of like the power of your application layer firewalls. Okay, so in the earlier days, we used to have stateful firewalls and then application firewalls separately. Okay, so there used to be devices who used to only do layer 7. And then we used to have stateful firewalls. So you would, in that case, place the application firewall either on the inside or either on the outside, depending upon the use case. Okay, but you really had to procure or acquire or deploy multiple products to secure things in your environment. Okay, and the need for application layer firewalls, again, it would be here for like a decade now. So when the requirements for, or when the attacks became sophisticated, the attackers and hackers, cyber criminals, they started using uncommon ports for a lot of different things. Okay, the need was there to build something that could also look at layer 7, not just rely on layer 3, layer 4. Okay, so which gets us, and let me just put this into the Gen 3 category here. So this puts us into our current scenario, our current gen of firewalls, which we call as NGFWs or next generation firewalls. Okay. Sometimes you are also going to hear the word UTM, which would be Unified Threat Management. Okay. Kind of like one and the same thing. Now, what is a next generation firewall? So next generation firewall is basically a stateful firewall. Plus, it also has the capability of being application aware. So it is also an application firewall. Plus, many more things. Okay. And when I am saying many more things, these many more things are, first thing, again, application aware. A very technical term for this is AVC, which stands for application, visibility, and control. Okay, so my firewall is able to have visibility about applications across my network, and gives you the ability to control those applications as well. Okay. Another thing which next generation firewalls are capable of is malware protection. Okay, which are basically viruses. Okay, so viruses are a type of malware. Okay, so this is basically two terms, mal and ware. So mal stands for malicious. Ware is software. So anything that is a malicious software, and what is a software? It's a code, right? And it could be written in any language, basically. So if a code is behaving badly or incorrectly, we call it basically a malicious code. And anytime there is a malicious software, a malicious code, it's basically called as a malware, which has various different forms: viruses, Trojans, remote access Trojans or rats, all of these different things. Okay, adwares, spywares, polymorphic viruses, stealth viruses, etc., etc.
So stateful firewall are not able to block malware protection.
Correct.
Okay.
Because if there is malware or if there is malicious code or any code, it would be in that layer 7 packet. Okay, that's where the data is actually. So since stateful firewalls do not have visibility beyond layer 3 and layer 4, they are basically blind to whatever is happening beyond that.
It is a stateful firewall, like up to
Right.
layer 4.
Right.
Yeah.
Okay, so malware protection, and malware protection has a lot of different things. You can have antivirus, anti-spam. Okay. Another thing that you can achieve through next generation firewall is they are user aware as well. So you can integrate firewalls with something like Active Directory. Okay, and you can have differentiated access based upon your Active Directory group. So maybe, for example, I want my sales and marketing team to have access to social media. I don't want my IT team to be able to have access to social media. Okay, so if I integrate my firewall with Active Directory, my firewall becomes aware of all the users that are present in my network. Okay, so my firewall can download those Active Directory group from the Active Directory and can take action upon it. Okay, so next generation firewalls are user aware as well.
Oh, if if we are not, syncing firewall with Active Directory, so how can you differentiate that, like on IP basis?
You
Like
can still do it based upon IP address. You can still based upon subnets, VLANs. There are lots of different things, different ways to do it.
Yes, yes. So, so we are able to segregate, no?
Right, you are still able to do it.
Yes,
right.
In a particular one department, two user can access like social media sites, and other can be denied.
Sure. Yes.
IP based.
Right. Okay. So you can still do your traditional way of doing it. Okay. But obviously, a much more simplified way is, since every organization, for the most part, has some sort of a centralized database. Okay, it could be Active Directory, it could be Sun Directory, Lotus Notes, can be anything. Okay, so it can fully integrate with your firewall, and the firewall can make use of that database as well.
So if we are, a particular group in Active Directory and integrating with firewall, so if we do require like that in account, some people, specific people, we are not able, should we access the social site. So where we have to work like in AD, so we have to pull back from that group, no? So,
right.
I just want to think that I will integrate a specific group from AD to the firewall, and the user should be in that group that want to use social sites. No?
Correct.
Okay.
So you can either configure rule to take action on that complete group, or you can choose specific users from that group. Okay, so if maybe you want to have all the users within the maybe IT group blocked except for 2 users, so you can block that complete group from having social media access, and then you can configure only those 2 users to be able to have access to social media. Okay, that's one way as well to do it. Okay, so there are different moving components to this as well, to the user aware. Okay, you can call this identity. Okay, the different ways to do it, I'll explain. We'll take a look at those, how we do this. Okay, there's a couple of ways to do it: active and passive. Okay, a lot of vendors from active, they basically call this as captive portal. Okay, and if a lot of you are new to the next generation firewall, the firewall world, and you don't understand some of these terminologies, don't worry, we're going to cover all of these in much more detail. Okay, and passive, from Cisco's perspective, it is done through ICE. Okay, it could be ICE or it could be ICE PIC server, passive identity connector. Okay, we're gonna discuss that, and we'll take a look at how things work. Okay, that's the user aware component. Another important aspect of my next generation firewall, or UTM, with respect, is being able to do SSL or TLS decryption. Now, majority of the traffic nowadays is internet-based or it's web-based. Okay, so people are moving to the cloud, organizations are moving to the cloud. Nowadays, we call cloud as the new data center. Okay, so people are using Dropbox, Office 365, everything is on cloud now. Okay, and everything is encrypted, that traffic, HTTPS. Now, I have been explaining that envelope, which the firewall can open and take a look at what's inside it. But if this envelope is further closed, let's say through, a tamper-proof envelope, which is our encryption, my firewall, again, becomes blind to what's really traveling in that encrypted packet. Okay, so my firewall needs to be able to have the ability to destroy this outer packet and be able to take a look inside that envelope or inside that layer 7 packet to see the traffic is not bad, it's not malicious, it's not carrying any viruses, it's not carrying any confidential documents, confidential files, etc. So SSL TLS decryption is another important aspect for our next generation firewalls, and very important in today's time. Web content security. Okay, what sort of a content are my users allowed to view or access on the internet? Okay, so web content security. You also have URL filtering, which typically is based on categories and reputation. Okay, so rather than creating one rule for every social media website out there, I can just say block social media. So social media becomes my category. And within that category, I would have, let's say, a dozen, 2 dozen websites which fall into that social media category. Okay, and then you have reputation as well. Okay, so the next generation firewalls, they need to know the reputation of websites which the users are trying to access. And when I say reputation, it basically means how trusted or how untrusted a website is. And typically the reputation is really marked from, let's say, a value of 0 to 5. Okay, 5 means the website is very trusted. Basically means that it does not host any malware, it does not deal with any malicious activity, it does not do spam, etc. It's a genuine website. Versus 0, which is the worst reputation. So obviously, when you're trying to protect your organization, you want your users to stay away from poorly reputed websites and content. Okay, and you want them to be able to, without any restriction, access.
Yeah, just my question is like this:
Yes.
how can we aware the user like that this is well-reputed sites and this is not?
I'll talk about that.
Okay.
Okay, so I wanted to talk about that later on, but I'll just mention that here is how is the firewall aware about this is through threat intelligence. So any firewall is basically threat intelligence. Okay, what threat intelligence is, so for example, for Cisco's threat intelligence team is Talos. Okay, and it's a dedicated group of individuals or security researchers who are doing research and who are trying to build these categories and reputations based upon that research. And this data that they build is then basically pushed to the firewalls over the cloud throughout the world. That's how their firewalls basically get aware about these categories and these reputations. It's because of this threat intelligence group. Okay, so these threat intelligence groups, they are basically working, doing research, seeing what's happening on the internet, what are the bad websites, what are the reputation, etc. And they're trying to build these databases, and they're trying to push these databases or do these updates for databases to the firewalls.
Okay. Only very small query is like that. How we Talos database manage like that? Any
You cannot manage it.
No.
So,
We are not managing, but how Cisco managing it? So there is any centralized organization that defines that this is like 5 rating website and this is the 0 rating, and then that database will distribute to like any firewall vendors like Cisco, Palo
they
Alto.
do their own research. They have their own team. Okay,
Okay.
so I would say there are about 200 plus engineers or researchers within the Talos group whose job is to do this. Okay, they also take into account third-party intelligence, like for example, VirusTotal. Okay, it's kind of like a third-party intelligence. You can go to their website. You can look at a couple of what they do. Let me just pull up a browser here. So let me just go over to Talos. Okay, so here, so if you're going to see this map, they have this map here, which is kind of giving you a rough idea about a lot of different things. Okay, so for example, anytime you see amber, these are spam. The green are basically malware. Okay.
Okay.
So
Okay. For these are the malware for the Cisco Talos, no? It might be a good software for any other vendor. Am I
not
right?
really. No. So it does not really work. So all the vendors here, they are not going to be conflicting for a common thing. Okay. So if Talos sees that there is a legitimate or there is a malicious website, Palo Alto team is not gonna, obviously, they're gonna do their own research, right? And then the security researchers are not gonna have conflicting information about a very common website or something which is delivering malware, okay? If we talk about software, yes, Cisco's firewall might pick up a software which might be legitimate and which might be picking it up as malware. And there are ways to mitigate that, okay? I'm right now just specifically talking about the URLs, filtering, and the categorization and reputation, okay? So for these softwares and everything, there's a different way to do it, okay?
Okay. Okay. So database also be lies on the Talos as well, no?
Right. Right, and everything is cloud-based, so you cannot really download and view what's in it. The firewalls, they connect to the Talos cloud, and then they download these databases automatically and dynamically.
Marik, just my curiosity is like this: how they manage it? Like, what in my understanding, any software that destroy is a legitimate software. Like I'm talking about like an Excel, MS Excel. So this is the valid from Microsoft. So Talos will fill up in the database that this software is a good software.
Right.
So any other thing that software, like I'm developing a software that will harm the and any other software. So
right.
So there is any centralized organizations that have the database like these are the good software, these are the not. So else these have the Cisco have own database, Palo Alto have own database.
Right. They have their own databases.
Okay.
Okay. So there is no centralized location as such from where they are pulling the database. Okay. Otherwise, they would not need to have their own separate teams to do the research and everything. Okay. So they have their own individuals who do their own research and develop their own database. Plus, they also take into account some third-party or open source or vendor-neutral databases, something like VirusTotal. Okay, so VirusTotal is kind of like an open source kind of a thing, so anyone can use VirusTotal's database. Okay, so Cisco, Palo Alto, Fortinet, they have their own database, plus they combine the database of such third-party vendor-neutral databases as well. Okay, but there is no one single central database from where everyone can pull the data. Okay, so they do their own research, come up with their own data, they take into account some third parties as well, and then they build their own databases.
Will include the license and part as well, no? During this course.
Sorry?
License structure of the firewall, no?
Right.
So it will define like license, which license for which feature.
Right.
I'm also.
I'll explain that. Yes. So when we continue with the training and everything, we're gonna talk about licenses, everything, what licenses are required for what features and everything.
Yes.
Okay. So that's the threat intelligence. Cisco's perspective, it's Talos, and everything is based on threat intelligence. Without the threat intelligence, just assume your next generation firewall to be a dumb device, okay? So it needs to have all the information before it can take action on it, okay? And we're gonna talk about all of the different threat intelligence that Cisco's next generation firewall needs or downloads, okay, automatically versus some of them which you can also download manually. If you know you have kind of like an air-gapped environment where you don't want to connect to the internet, DoD, military, and all those areas where you have air-gapped networks, air-gapped environments, they don't allow connections to the internet. For those places, you can download manually these databases and also install them. Okay, but the typical recommendation is to be able to do these automatically, periodically. Okay, the threat intelligence, and a lot of next generation firewalls also provide you to be able to do some sort of a web proxy. Okay, email protection. This is already covered here in as far as the anti-spam is concerned, so I'll just do away with this. Okay, and you have DLP or data loss prevention. Okay, it can provide in a lot of places. It can also do, again, your VPNs and everything is another thing that it can do, both your site-to-site and your remote access. Okay, so, and there are a lot more things that it can do. So now with these current generation or these newer generation firewalls or devices, we are able to do so much, and we are able to protect our environments so much with just a single device. So now there's no need for you to deploy 5, 6, 10 devices to be able to fully protect your environment. That's why you would also sometimes hear the word UTM, Unified Threat Management. Okay, because there is a single unified device who is taking care of all the threats that might happen or might be present in your network or environment. Okay, so every vendor out there who is doing next generation firewall, okay, so every vendor out there which has a firewall, it is a stateful firewall, it is a next generation firewall, and it is able to do all of these things. Okay, so it's not really just Cisco doing this. Every vendor can do this. The terminologies might be different. Okay, so for example, just for an example, threat intelligence, Cisco has their Cisco Talos team. Palo Alto has what they call as, I think they call it Area 52. Okay, Fortinet will have their own intelligence team who would be really doing the intelligence work and sharing the updates. Okay, so every vendor that does next generation firewall is doing all of these features. Okay, we are trying to understand it from the perspective of Cisco. So from Cisco's perspective, previously, and I'll talk more about this tomorrow, but just to give you a very brief of this, Cisco calls it, or used to call this, firepower threat defense. That's the name of their next generation firewall. Okay, this name has now changed and it's now called as Cisco Secure Firewall. The functionality has not changed. The functionality and everything remains the same. It's just that Cisco has gone through some naming changes within their security portfolio, and this is the new name that they have for their firewall, for the next generation firewall.
Oh, okay. So FTD now like Cisco Secure Firewall.
Cisco Secure Firewall, yes.